Hi everyone and welcome to this lecture series on network analysis. Today's topic of discussion is voltage sources and current sources. So let's first move to voltage source. Voltage source may be of two types. One is an ideal voltage source. As you can see, this is an ideal voltage source, and the definition of an ideal voltage source is that uh, the voltage across its terminal remains constant irrespective of what the magnitude of current or direction of current drawn from this source. You can see that with the load current or the terminal current, and then the terminal voltage Vs remains practically constant. This is an ideal voltage source, but this type of source are actually not occurs in practical circuits. In practical circuits, what is found is and and non-ideal voltage source or practical voltage source which has a small series resistance in series with this source. So what happens is that when as you increase the current or as you draw more current from this source, the voltage across the terminal will slowly drop off, and you can see that the voltage is dropping with the increase in current. So another type of voltage source is dependent and voltage source, and it's usually denoted by this type of diamond marking with polarities given like this. So what now this is an independent source, and the difference between this is that its magnitude is not independent of any other voltage or current, but magnitude of the dependent voltage source those depends on the magnitude of currents or voltage in another part of the same circuit. So let's move on to another source found in electrical circuits called the current source. So the like similar to a voltage source, there is also an ideal current source and practical current source. Those in ideal current source, you can draw any amount of current from this. You can have any voltage across this terminal, irrespective of the current. Current is constant, irrespective of the voltage across this terminal. But actually, in practice, there is a small series resistance, small resistance in practical in parallel with this is sources. And, and actually this is a dual network of the voltage source we showed on the earlier circuit, on the earlier slide. The voltage source was Vs is in series with an resistance, and and this is a dual. I love this uh, current source of this current source. This is a dual source of this now like voltage source. Current source can also be dependent and independent. Dependent we usually denote this as a dependent source with a diamond shape, and its magnitude depends on another voltage or current in different part of the circuit. So, so voltage sources in series. How can we actually when we are given to reduce or a circuit or find a voltage across any element, and maybe a resistance or capacitance or inductance, and these rules are very helpful in circuit reduction no circuit synthesis, and then that is called DC voltage source in series can be replaced by a single source. Yeah. AC voltage in series can also be combined into a single source. But we will see that there is a kind of frequency and phase as with an AC source. Those DC and AC voltage source can also be added together in series in calculating the voltage across the combined and circuit. DC voltage source operating at different frequency can be edited and also he edit together. And all this can be done with a theorem called superposition theorem, which will be taken up in a later video of superposition theorem. Now let's move into